In this free algo trading bot course, I asked the latest version of the AI platform ChatGPT to come up with an easy to follow Python EMA trading strategy. And let me tell you, what it came up with blew my mind because the gains were absolutely insane. And I'm gonna show you the exact settings that led to these gains in today's video. Here are some of the amazing results I was able to come up with after taking the code ChatGPT gave me and testing over 70,000 different possible settings so we can make sure we have the best of the best settings to use live. The Quant Freedom community and I built this multi-threading backtester with only one thing in mind: speed, and even more speed. This allowed me to backtest over 1 billion candles in only 10 minutes. So as you guys can see, this isn't a joke. If you watch everything in this video and you come to the live stream and join the Discord so you can be a part of the community, you will be well on your way to becoming an amazing algo strategy developer. And it all starts right now. All right, let's start out this video the way it needs to be started, which is letting you guys know that the version of Quant Freedom that we have to use in this video, if you want everything to work, is pip install Quant Freedom 0.2.1.0. And that is thanks to someone in the live chat saying, hey, don't forget to talk about the version of Quant Freedom. And also don't forget to talk about the virtual environment that needs to be created. So thank you in the live chat for that. So in order to do that, the first thing that we're going to need to do is come down here and actually create our virtual environment. Now, I have a folder called coding where I have all of my different projects and all this other stuff and my virtual environment. So I'm going to need to have my command line open, or whatever you call it on a Mac. I'm going to go to my virtual environments folder. And in here, I'm going to type Python -m then v q free. Now, I think if you're on Mac, you have to do Python 3. But anyways, this is what you want to type. We're going to hit enter. And this is going to start creating our virtual environment for us that we're going to be using in this, this tutorial. That's what it's called. And the next thing that we want to do is we want to do, I have a folder called YT videos. And so you guys can see here, this is the folder called YT videos. And inside of that is where I have this EMA cross strategy and some of the other strategies and different things that I've been working on for YouTube videos. So this main folder right here houses all of these other folders. So we need to add this folder to our path for our virtual environment. If you don't know what that means, then basically that just means we can use anything and everything in this folder while we're using this virtual environment, because we've added this path, YouTube videos, to the folder. So that's what we need to do. And an easy way to do that is to do echo, and then we're going to do coding, and then I'm going to type in YT videos. All I do is just type Y and then I press tab. So we're going to echo this. So that just basically means we're going to print this, I guess you could say, in command line terms. Then we're going to do caret. That means write to a file, and we're going to name that file my paths.pth. Now, if you're on a Mac, I'm not sure exactly if this will work. I think it should work, but if it doesn't, come into the Discord, let me know. Come into the live stream and let me know. I obviously have Windows, so this is what it works on Windows. And so now we're going to run that. And so everything should be working properly fine here. So what we're going to do is we're going to check, and you will be able to see here that I messed it up. So we need to actually cd into qfree and then run this. Okay. So what we're doing here, if we go into the actual file here, you'll see that we have a my paths. And if we open that up, you'll see we have coding YouTube video. Okay. So what I did previously is I messed that up and I accidentally added it into this because I wasn't paying too much attention. So it's all good. All right. So now that we have that, what we need to do is select the interpreter. So the way I'm doing that is I'll go into qfree scripts, and then I have this python.exe. I'm not exactly sure, again, what it's called on Mac, but it's kind of in the same area. You want to just find your Python file. And then we want to do select interpreter right here. So I did Control-Shift-P, select interpreter. And then you want to enter this path python.exe for me. If you're using a Windows, you can just enter the interpreter path by finding it. If I click this, then you do find, and that works. But for whatever reason, on a Mac, it seems to not work as of making this video. I'm not sure. Again, I don't use a Mac. So this right here, boom, we hit enter. And now you'll see that if it worked, you'll see you should get this little warning here saying, hey, we need to make a new command, or we need to make a new terminal that activates the interpreter that you just selected. So if we hit this, now we should allow, well, let's see if this actually is going to work. Let's see. Well, what's going on here? Okay, I normally just do enter interpreter path and then I actually go and find it, but apparently all I have to do is just type Python instead of the .exe, and then you hit enter and then everything should work perfectly fine. So now if we go to our terminal, we'll see that we have this queue free right here, and then if we also do select interpreter, you can do it like this. Okay, so now we have this random thing here with this python.exe that I messed up on, but that's fine, doesn't matter. You live, you learn. We refreshed it, now it's gone. So yeah, we want to use this one right here. E-coding, venvs, queue-free scripts, Python. And then we select that, and now we have our Python selected. And then also, anytime that you're going to be using a Jupyter Notebook file, like we'll just do test.ipynb, that's a Jupyter Notebook file, you want to make sure that you are selecting your kernel right here, and you want to do select another kernel, Python environments, and then we have this queue free right here, and then it tells you exactly which Python version, 3.12.4. And so now that we have this right here, what are we going to do? We're going to come up to here. I'm just going to copy this. I'm going to paste it in there, and then this is what you want to type: pip install quant freedom equals 0.2.1.0. And you want to make sure that you have this queue free right here, or whatever you named your virtual environment. And you want to press enter, and it will go ahead and download everything that it needs to download. This process could take a little while depending upon your, whatever this thing is called, how fast your computer is. That's what it's called. It's called a computer. And I'm going to pause this until it's done. Now that everything is done installing, we should be able to go up to this blank Jupyter Notebook file and just do from Quant Freedom, import DL, EX candles or whatever, and it should work now. So we have our kernels working, our interpreter is selected properly because we have it here. Everything is installed properly. We have the correct version of Quant Freedom installed, and everything should be good to go. So again, thank you to the person in the live stream that was asking that question. Now let's move forward in today's video. All right, let's start out with the first cell being the imports and all of that stuff that we're going to need to do. So as you guys can see here on the screen, we're going to be importing numpy as np, plotly.graphObjects as go, from pickle import dump, from datetime import datetime, from quant freedom import dl ex candles, from quantfreedom.indicators.tv indicators import ema tv, and load ext auto reload, and then auto reload 2. All right, so just take your time to do that. Somebody in the live chat is saying, hey, you're going a little bit too fast, can you slow down? Just when you're watching the video, pause and go over that, or you could just pause the live stream and then come back. But this is exactly what it is. Well, I'll give it a little bit of time to go ahead and do that. So I'll pause the actual video and you could watch the live stream. All right, we're back. So the thing that we're going to do now is get the pickle file path. And so I already have a pickle file path that I use. And so I'm going to go ahead and copy that over here. So now we can see here that I have a folder that I called coding on my E drive. And inside of that, I have all my projects and all my different things that I'm working on. Okay. And so from there, I have my coding, my candle databases. Then inside of my candle databases, I have my pickle files. And then I'm going to name my pickle file this right here. Okay. And so that's going to be .pkl. That's very, very, very important. Is the .pkl is how we are going to save our pickle file. Okay. So now we're going to move on to actually downloading the candle. So how do we do that? So we're going to do candles equals dl ex candles, and that's going to take an exchange. And the exchange that we're going to use is mufex. And so the next thing that we're going to do is symbol equals BTC USDT. And we're going to do time frame equals 5 minutes. Since date time equals date time. We're going to change this to 20, 23, 10, and we're going to use 11. And the next thing that we'll do is we're going to do our until date time, and we're going to do 2023, 12, and 5. All right, and I can see there's a question in the live chat from one of the subscribers, and they're asking about the exchange. And so we're using mufex here because that's the exchange that lets you download from anywhere around the world. You don't need to do any kind of computer vacation time to another country or any of that other stuff. But I would also say for the rest of the video, just follow along with what it is that I'm doing, and then you can go and change the dates, you can change the symbol, you can change the time frame, you can change everything that you want, and you can also download from some of the other exchanges that Quant Freedom has. But for now, just follow along with everything that I'm doing so that we're all on the same page, okay? And so we'll just hit enter here, and this is going to say DLEX candles is not whatever, and that's because I didn't actually run this cell. So now we have to run this cell. So now the Jupyter Notebook knows that this thing exists and it's in its memory. And now we can do this, and it's going to download the candles. It's going to take a little bit of time. And then now we have our candles downloaded. All right. So now that we have our candles downloaded, we need to go ahead and save those candles. So how do we do that? Well, this is how we do it. So we have with open, then we're going to have our pickle file path. That you're going to have a different pickle file path than me. Or maybe you don't. Maybe you have an E drive encoding in candle bases just like I do, but you're going to have your pickle file path. Then we're going to have this as WB, which I think stands for write bytes. And then as F, which basically is just like do all of this stuff as F. And then dump is from pickle. We're going to take our object. You can see here our object is candles. And then it says here our file is F. And this is our file basically. And this is our candles, and we're going to put these candles into this file. And once we do that, we'll be able to, if you went to this file location, you would actually see the pickle file there, but I'm not going to do that. You just have to understand that it's there. Okay, and this is for later on when we're going to be using the same pickle file for other reasons, for backtesting and different things like that. We don't want to have to keep downloading the candles over and over and over again. All right, and so in the next part, we're going to be going over the first creation of the strategy, which is doing the EMAs and stuff like that. Okay, now it's time to save our variables that we're going to be using. And so here we have the first EMA length. So that's just going to be our first EMA. We're getting our length is going to be 50. Second EMA length is going to be 140. We're going to be saving candle close prices. This is going to be candles.candle close prices. And date times is going to be candles.candle open date times. Okay, so all of those variables are going to be used in the future. And so let's go ahead and just run that cell. So now we have our variables saved. And the very first thing that we're going to do is we're going to create our first EMA not rounded. Okay, an EMA TV. And the first thing that we're going to do is we're going to do source equals candle close prices, because that's what our source is going to be. And our length is going to equal first EMA length. So now what this is going to return if we go ahead and run this is you can see here that we have all these extra decimal places that we don't really need, because if we're looking for something as simple as like is above, is below, or something like that, we don't need it to be this granular. Like, you know, if this is a 9, but yet it's all the way out here to this decimal place, we don't want that. We just want to have 2. So we're going to have this. We're going to say first EMA equals np.around, and we're going to throw it first EMA not rounded, and we're going to say decimals equals 2. I think that's how it works. We're going to say a equals, I think you can do a equals and decimal equals. And if we go first EMA, then we'll see here, now we have rounded EMAs, 2 decimal places. I think that 2 decimal places is just perfectly fine. And so now we have our this is basically called our current EMA, okay? And so now we need to make our previous EMA, because we're going to be doing some comparisons later on. where we are going to be comparing to see if the current EMA, which is this first EMA, is above our second EMA. And then we're going to say, is our previous EMA below our second EMA? Okay. And so it'll make sense as time goes on, but that's why we're doing this. So first EMA P equals np.roll first EMA, and we're going to roll it by 1. So what this means is that we are taking this array right here and we're shifting everything to the right 1, but we don't want this, because what this roll does is it takes this very last one and puts it first, and we don't want that. So now we're going to have to do first EMA P0, which is the first element of it, and we're going to say that that's going to equal np.nan. np.nan here. Okay. And so if we print first EMA P, and then we print first EMA like this, you'll see that here we have this here. So this is the current EMA and this is the previous EMA. This is the current EMA, this is the previous EMA. So if we have the current and we want to test it against the previous, which would be this one, right? So this is the current, this is the previous. Well, now we have it. Now we have 2 EMAs. We can test each one in the same element. So whatever this is, I guess would be like -2. So here we would test this element versus this element. So that's extremely important with what we need. So now the next thing that we're going to do is we're going to copy all of this, except we're actually going to delete these prints because we don't need prints. So I'm going to copy all of this and just paste it over here. And then I'm going to hold Alt and click wherever I see in front of first, because that's all we're going to need to change here. It's first. And we're going to delete all this and we're just going to do second. Okay. And that's it. All right. So one of the subscribers in the chat says, hey, I messed up on my alt clicking. What do I do? So if you were like, say you were trying to change all these EMAs or something like that, and then you accidentally click like here, or then what you do is you just hold Alt still and click it again and it'll go away. And then you click in front of it again like that. So you can just make it go away by double clicking it like that. Okay. And so now we're going to have our second EMA. And so everything, as long as let's just double check to make sure that we have everything here. So we have our second EMA, the source is still going to be the same. Second EMA. Let's get rid of this E and this A. I don't think it's necessary. And then this decimal 2. And then let's get rid of this. I normally just like to have the equals so that way everything makes sense. But the A, I don't know why they named it A. Just like with here, the roll, I think it's A. I guess A stands for array-like. And then here we have this 1. So let's go ahead and just run this to make sure that it's still going to work, and run this to make sure that's still going to work. So now we have our 2 EMAs, right? So now we have to actually do the creation of the entries, the true and false signals that we are going to be generating based off the strategy that we're doing, where we are having a first EMA crossing above the second EMA. Now let's start creating the actual entries. So first thing that we're going to be doing is I'm going to call this current first above second. So this basically stands for the current first EMA is above the current second EMA. Okay. And here I'm just going to say first EMA is greater than second EMA. And so what this is going to do is, okay, well, I'll explain all this stuff later. Then the next thing I'm going to do is I'm going to do previous first above second. Previous first above second. And this is exactly why you should not use AI or autocomplete unless you know what you're doing, because this is not what I want to do at all. So first EMA, here it is. So, well, that's not it either. So first EMA P is less than the second EMA P, right? So here we're saying the current first above second is the current first EMA is greater than the current second EMA, and the previous first above second is not what I want to do either. So below first, previous first EMA is below the second EMA. So what does that look like? That looks like this, right? So if we have this, let's just say that this is our first EMA. So it's going to come down like this and come up like this, right? So then let's say that we have our second EMA. Let me change this to yellow. And so it's like this. And then it's coming down, and then it comes up a little bit like this and does this like this, right? Okay. So here we have our first EMA is above our second EMA, and our current is always above. Its current is always above, always above, always above, always above, always above. Boom. Now we cross. So now our first is below. So this situation right here is going to be true, 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 true. And then this previous first is going to be false, 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 false. It's still going to be false because the previous first is not less than the previous second. The only time it happens is here, right? Is right here. So we have the first previous is less than the second previous right here, and the first current is greater than, so that only time that is true is right here. Right here, okay? So let's imagine this is a candle and this is a candle. So at this candle, we have our first previous is below our second previous, and then at this candle, our first EMA current is greater than our second EMA, right? So that's how you get the true signal. So that's how you get your entries. So entries equals current first and previous first below. Okay, and that's how we end up getting our true and false. So the next thing here is our entry signals. Now this is going to be for our plotting, and so this is going to be np.where entries, and then we're going to say first EMA and np.nan, and then our exit prices is going to equal np.full like, and we are going to have our first EMA np.nan. Okay, and so again, we have a subscriber in the live stream asking if they can see what the entries looks like versus the entry signals. That's actually a pretty good question here. So let's go ahead. So the entries looks like this. So we just have, again, entries is going to be nothing but true and falses, because the way it works is only when this is true and this is true do we get a true. So it has to be true and true in order to make a true array. Okay, so that's the way it works. All right. And because even if you have false, false, that's still false. If you have false, true, that's false. If you have true, false, that's false. If you have true and true, that is a true statement. Okay, so just think of it like that. Two true statements will only make a true statement. Okay, you can't have a true and a false. That would be an or. So true and true, then you get a true. Versus the entry signals. The entry signals is basically saying np.where entry. So where we have a true, put the first EMA, which are numbers. So put the number, because that's what we're going to use in order to actually graph this. Else, if there's a false, wherever there's a false, put np.nan. Okay, so we're going to put not a number. And the exit price has to do with the Quant Freedom backtester. Okay, so we have all of this, and now we're going to be able to take everything that we've done so far. We're going to plot it to make sure that I'm just not out here talking out of nowhere. Okay. And for other people that are watching the YouTube video, if you guys want to be a part of the live stream, you just go down to all the social links, click on that, and it will tell you the link for my live stream. Okay, so now let's go ahead and do the graphic. Now we have to plot in order to make sure that we actually know what we're doing instead of thinking that we know what we're doing, like some of the situations that I've run into with myself. I think, oh yeah, this is correct, and then I plot and I'm like, oh no, this is 100% not correct. So this is not a Plotly course or tutorial. I have those on my other channel. If you guys want more information on that, you can go to join the Discord and ask for that if you need it. But for the most part, if you watch enough of these tutorials, you'll see that we're basically doing the same thing every time. You want to do fig equals go.figure, we're creating and then here we want to add a candlestick to that figure, which is just X equals date times, and then open equals candles open, high equals candle highs, low equals candle lows, close equals candle closes, and the name is going to be candles. And then we want to add a scatter, and here it's just going to be X is the date times, because that's our X axis, and our Y axis is going to be our first EMA, and the name is going to be first EMA, and it's going to be a line, and we're going to create a dictionary, and the color for me is going to be yellow, and I like the width to be 3, so that way it stands out a little bit. And then the next thing that we'll do is we're going to go figure, add scatter, and it's going to be date times. Y is going to be the second EMA. That's going to be our second EMA. And some people call it fast EMAs. Some people call them slow EMAs, fast and slows. But I'm going to show you why I don't call them fast and slow. I call it first and second because we always have these preconceived notions, and then you do a backtest and you're like, oh my God, I was absolutely wrong. And then the next thing that we're going to do is we're going to put our buy signals. And so here we're going to have our date time, our entry signals, right? Remember, those are actual numbers. They're either nans or actual number. It's going to be a buy signal. It's going to be a marker. And then our mode is going to be marker. And our marker is going to be size 8 with a circle. And it's going to have this color right here. We're going to update our layout so that way the height is 600. And our, I hate this thing, x-axis range slider. And we're just going to show it. Okay. And so here we are going to load that. And so you guys can see, if we zoom in, that's what you always want to do, is zoom in to make sure that it's doing what you actually want it to do. So let's go ahead and zoom in here, and let's zoom, so you guys can see if we expand this a little bit like that, and we move this out like so, and expand it a little bit more. So let's move this up. So we can see here that everything seems to be working perfectly fine. I think we might have to zoom in even more on this little area to be able to see. So you guys can see here that this candle, like we said in the example, the first EMA was lower than the second EMA. And then this candle right here, at the current spot, the first EMA is above the second EMA. So we can clearly see that is happening. And so that's how we get our signal showing up. Okay. So that's a good thing. So let's zoom out a little bit. Let's see if we can move. I saw another situation where we had a little bit of a cross. See if we can scoot over to that. We have a downward cross. We don't get that. Here we have a cross. So this is even more clear, except our candle is way up here. But you can see here, first EMA is below, second EMA is above. Then our next candle, the first EMA is above, our second EMA is below, and therefore we get our signal. Okay. And so now we are seeing, if we want to, you guys can go through. I already know that this works. So we have that. We're just confirming that this is basically actually working. And again, we have another question again from the live stream. And so they're saying, why did you do go.figure instead of go.figure every single time right here? So we want to create an instance of this class and save that as a variable. And then that's why you have this add. So we're adding to this figure class that we have made, and we're adding to this figure class that we made, and we're adding to the figure class that we have just made. Okay, so that seems like you might need the beginner's course for going over classes and different things like that. So make sure that you just ask in the Discord about the beginner's course, and I'll go ahead and send that. And that also is for the people on the YouTube video. If you need a beginner's course or you're anything like that, again, go down below to the social links, click on that, then go to the Discord, and then all you got to do is just ask, unless there's already a link to the beginner's course in the on the social links. Okay, so now that we have this, and thank you for your question, by the way. Now that we have this, so now we've confirmed that our strategy actually is working as far as it's plotting what we need to do. Everything is working like we need to do. What we need to do now is actually go ahead and go through the process of backtesting. So when it comes to turning this into a class to work with the backtester, one of the very first things that we need to do is create a folder with the name of the strategy. So inside of my folder right here, I'm going to create a folder called EMA cross. And inside of that folder, the very first thing that I'm going to do is create this file called tuples and variables.py. Okay, so now we're going to be working with our Python functions. And so I'm going to move this over, and inside of this, we're going to have to do import numpy as np, and from typing import named tuple. Okay. So the very first thing that we need to do is create a thing that I'm calling an indicator settings, which is basically going to be our length of our EMAs that we created earlier, which is these two things right here. So first thing that you'll need to do is do class indicator settings, and it's going to be called name tuple. I have to put this S here. And what we'll do here is we're going to do first EMA length, and that's going to be an mp.nd array. And it's going to be an array because we're going to be able to feed it multiple, like we can test 10, 20, 30, 40, 50, 60, 70, 80, 90, like as many different things as you want. So we're going to need it to be an array. And the second EMA length is going to be an np.nd array. Okay. So the next thing that we'll need to do is we're going to need to create a backtest setting tuple. So here we're just going to do backtest settings tuple, and that's going to equal backtest settings. And this comes from Quant Freedom. So what you'll need to do now is we're going to do from quantfreedom.core.enums import backtest settings. Okay. And so what this basically is it lets you filter things out. So like if you're trying to do tons and tons and tons of different settings and different all types of different things, and you're going to come out to having like thousands and thousands and thousands and thousands of results, maybe we don't want to see anything that's less than 0% gains, or we don't want something that has like less than 10 trades. So this is where you can go ahead and mess around with these and say, hey, usually what I like to do is just say the gains percent filter is 0. And I like to say the trade filter, depending upon the length of time that I'm doing, is going to be like 10 or 5 or something like that. Because sometimes you'll get like tons and tons of results, and that's just going to be a waste of space and a waste of data. So that's why I have this backtest setting. And again, if you need to learn more, you can check out the website, or you can come to the Discord and ask me. And all of that stuff, again, is linked down below in the social links. And so the next thing that we'll need to do is we're going to create an exchange setting tuple. Now this right here, again, we're going to be testing on mufex, okay? And so here, if we just hover our mouse over this, all we have to do is just put a comma here, and it's coming from there. So this is how the backtester calculates certain things based off of how the exchange works. So the mufex exchange, here, the asset tit step, that's going to be the asset size of when you're placing a trade. So for Bitcoin, it's 0.001. So it works in tick steps of 3. The leverage mode here is going to be 1 for isolated. The leverage tick step is 2. Limit fee percent. This is how much it costs to get into a limit order. This is how much the fee is for a market order. This is the maximum size that you can do for as like 100 Bitcoin trade. The maximum leverage, the minimum asset size, the minimum leverage, the MMR, which is your I forget what the name is, but all of the exchanges have this. And here the position mode is going to be whether it's going to be cross or hedge, and the price tick step. Okay. So these are the things you guys can just copy this down, or if you need the files, again, you can follow the live stream. And then come to the Discord. Let me know you followed the live stream, and I can send you the link to the files as well. All right. And the next thing that we're going to need to do is create a static order settings. Okay. And here we have this. And so now we're going to have to add all of these things here. So we're going to say static order settings. We're going to say increased position type. We're going to say, what else is there? Leverage strategy type. And we have the rest of these. Strategy type. See, the AI thing has no idea what it should be typing in. We'll do this. So I'll explain a little bit about all of these. Again, if you guys need the video that it goes into more detail about these things, which is really important, then I will let you guys know. Well, again, for every question that you have, the solution to that is always going to be follow the live stream and join the Discord. Those are all, anytime you have a question about anything, the answer is always going to be that. Okay, So our increased position type, this is going to be we are risking a percent of our account for every trade. So if we have, I want to risk 100, I want to risk 1% of my account. So if I have a $1,000 account and I want to risk 1%, 1% of 1,000 is $10. So every time we are going to get stopped out, it would be risking $10 if our account constantly stayed at 1,000. As it changes up and down, it's always going to be risking 1%. The leverage type is dynamic. That's a quant freedom leverage strategy where it puts your liquidation price right below your stop loss. Here, since this is going to be a long strategy, we want to get the minimum. And this is going to be stop loss based on candle body, which we're going to say is going to be the low. Later on, we're going to be talking about that. Then we're not going to move our stop loss to break even. We want to give it a 100 candle buffer, which is why we're doing here. Our starting equity is going to be 1,000. We are not going to be using our static leverage. Our take profit fee type is going to be limit because we're going to be limiting out of our position as we take profit. Our take profit strategy type is going to just be risk to reward. And our trailing stop loss strategy type, we're not going to be trailing our stop loss. And here we are not, since we're not going to be doing our stop loss to break even, this is also going to be none because this means basically like, do you want to make sure that your stop loss, if you move to break even, is going to be losing $0, or do you want it to be at even, right? Is it going to be equal with where your current position is at? And again, as always, if you have more questions about it, you come to the Discord. All right, and the next thing that we will have set up for us is our dynamic order settings, okay? So let's go ahead and put this up here, like always. And our candle body type. We'll go ahead and put that here. All right. So this, we are risking 20% of our account, according to this thing, risking 20% of our account for every trade. Then our maximum amount of trades, we're going to test 2, 4, and 6. For this part, this is the part where I suggest you do not follow along with me. Well, I am going to comment this out. Well, yeah, I'm going to comment this out and I'm going to paste it again. So uncomment, copy, comment, and paste it. So I'm going to test this later on, but for the first part, for just making sure that this thing works, we're just going to do one of these. So let's put this at 5. We'll change this to 3. Oh, let's change this to 5. 5 to 1 risk to reward. Here, this is going to add extra percentage to our stop loss. So if we say we want to put the stop loss at the low, which is what we are doing here, then yeah, we're putting our stop loss at the low. So then we're going to add like 0.3% to it. So let's go ahead and do this. Then we're going to, this right here, the stop loss based on look back is going to look back 30 candles from the current candle, find out whatever the lowest low is and put our stop loss there. And then here, this is saying based on the candle body low. And then here, this is a stop loss to break even type. We're going to put nothing. So we put 0 here for when it's talking about moving our stop loss to break even. And here we are not trailing our stop loss. So we're going to put this at 0. We're going to put this at 0 as well. Okay. And so all of this right here has to do with our back test. This right here has to do with our back test. This right here has to do with our back test. And obviously this right here has to do with our back test. And this is going to be something that is associated with the actual strategy, like the creation of the strategy. So that way we can work with it as well. And so again, we have a question from a subscriber in the live stream. Somebody's asking, why do you have, or a subscriber is asking, why do you have a static order settings and a dynamic order settings? And the reason is because these static order settings are things that are just never going to be changing, right? As you can see, each one of these is not an array. It's just a one-time thing. Like this equals this, this equals this, this equals this. We're not testing anything differently, okay? The dynamic order settings is exactly what it is, dynamic. That's why all of these things have to be NumPy arrays, because it's possible that you could have multiple different options because we want to test these things. Like we want to test how well our strategy does if we add a little bit of a little bit extra. Like I want to test 0.5, 0.3, 1%, 2%. I want to test multiple different trailing stop losses. I want to test multiple different risk to rewards. I want to test multiple different maximum amount of trades, different things like that. Okay. Whereas a lot of these things aren't going to change. Like our starting bar is not going to change. Our limit fee is not going to change. We're only going to be testing this particular strategy and stuff like that. So that's definitely a really good question. So I appreciate that question. All right. Now we have to make the main Python file, which and it's going to be inside of the EMA cross folder. And it is going to be called EMA cross class.py. And we also need to make an init. So init.py. All right. So here we're going to do import numpy as np. Then we're going to do from os.path import join and abs path. And then we are going to do from quant, I did not mean to press tab there, from quant freedom import footprint and strategy. And I think that is it for right now. Okay, well, then we also have to import our tuples that we have made. So we're going to do from EMA cross. I think we have to do it a little bit different than that. Okay, I had to make some changes to how I was labeling my my folders here, and so you can't have numbers as your first part of your folder. So I had to change this to EMA cross 00. Then I had to change this to strat 02, then EMA cross. And from here, what we're doing is we're doing from EMA cross 00, strat 02. You can name these things whatever that you want, but all I'm saying is here you can't have any numbers as the first thing. And then you'll have this. So we're going from EMA cross 00 to strat 02 to EMA cross to tuples and variables. And we're going to import indicators, static order settings tuple, exchange settings tuple, and backtest settings. Okay. Then we're going to do from logging import get logger. And we're going to do logger equals get logger and just have this like this. So that's what we need so far for our imports. And then now we're going to start just making the class. So the class is going to be class, then it's going to be EMA cross, and we're going to also send it strategy. Now strategy comes from the Quant Freedom project. So we'll explain why that's important later. So first thing that we're going to do is just do entry signals. So now what we're doing is we are creating the variables that are going to be going along with this class. Second EMA, np.array, first EMA, np.array. Then we're going to do current indicator setting tuple is going to be this. And we're going to do OG indicator settings tuple is this. So these are variables that we are going to be using eventually later on in the class, which will make sense as we start using the variables. But for now, this is what we need to have in order to actually get this thing up and off and running. Okay, so first things first, with most classes that you're going to be working with, we want to do a init. So def init, and we're going to pass itself, and then we're going to do first EMA length is going to be an np.array, our np.ind array. And the next thing that we're going to do is we're going to do second EMA length np.array. And we're going to do, oh, wait a minute. Oh, yeah. And then we're going to do shuffle bool. And that's going to be a bool. Okay. So we'll just go ahead and put this up here like this. So we have our first EMA length, our shuffle bool, and our second EMA length, or I read that backwards. So anyways, we're going to put this here, and then we're going to do self.log folder. And this is where our logs are going to go once we start doing our back testing. So that way we can make sure that we're checking on things. And it's going to be absolute path, and it's going to be join, and then we're going to do absolute path. And here we're just going to put this like that. And the next thing that we're going to do is we're going to say dot dot like this. So what this is basically going to do is basically say, give me the absolute path of this file right here, and then go outside of this folder. That's what this dot dot is for, and store the logs here. So you guys can do it however you want. And as time goes on, we'll show you exactly where this log is, or you could just send it an exact path of where you want your logs to go. But that's how I'm doing it. And then self.static order settings tuple is going to equal this. So again, we're importing it from our tuples and variables, and we're going to save it as a self. So that way we can use this no matter where we create this class. Then here we're going to do self.exchange settings tuple. And then we're going to do self.backtest settings tuple. And then what we will do after that is we are going to create our indicator settings tuple. So ind set tuple, and we're going to just do this. So here we have ind, which stands for indicator. Then we're going to say settings, which is set, and then tuple, and that's going to equal this right here. So I normally like to do the equal sign, just so that way it makes more sense. Even though they're the same thing, I like to have the equal sign because it lets me know that this is going here and this is going here, just in case you had it out of order. You can never have it out of order if you don't use equal signs. I personally like to use the equal sign. Some people don't, but hey, that's what it is. Okay. So now we have everything that we need for the very beginning part of creating the EMA class. And so now we have to work on some of the other files that go along with this class, so that way we can start to really take the strategy that we have and turn it into an actual class. So now what we need to work on is getting ourselves set up to make it so that way we do the Cartesian product of the dynamic order settings and as well as the indicator settings. So what that basically means is we need, like, let's just take this for example. Let's just say we have this. So we have 3 options here, 3 options here, and 3 options here. That means that we have 3 times 3, which is 9. So there's a total of 9 total possible combinations when you put these together. Then we're going to add these other 3. So it's just 3 times 3 times 3 times 1 times 1 times 1 times 1 times 1 times 3 times 3. So there's going to be a total of, like, I don't know, 1,000 different combinations that you can put together with all of these, right? Then we also have to get the total different possible combinations that we're going to throw into here. Like maybe we want to test 10, 20, 30, 40, 50. So what we're going to do is we're going to get the Cartesian product of all of the total possible combinations that we're going to come up with. So now we have to start making that file. Okay. And so here, what we'll do is we're just going to name this DOS end cart funcs, and it's going to be a PY. So this is just, for me personally, this just stands for dynamic order settings, indicator settings, Cartesian product, function. So these are going to be the functions that are going to handle all of that stuff. All right. And so from here, we're going to do import numpy as np. Numpy as np. We're going to do from logging, import get logger, from quant freedom, import strategy and dynamic order settings. And here we're going to do from EMA cross variables, and we're going to say indicator settings, and we are also going to do DOS tuple. Okay. And logger equals get logger. All right, so the first thing that we are going to do is we're going to need to create the main function on how we're going to actually get the Cartesian product. So we're just going to call this def get og end and DOS tuples. And from here, we're going to send it the end setting tuple, and that's going to be indicator settings. And then here we're going to do shuffle bool, and I'll explain what this shuffle bool is a little bit later. And this is going to return a tuple, and it's going to be dynamic order settings, and it's going to also return an indicator settings. And I messed that up. So here, and we've got to put this little thing right here. All right. And from here, the first thing that we need to do is we need to do og strat equals strategy. So we are creating this strategy class, and you'll see why in a second, okay? And the first thing that we need to do is we need to we need to get our Cartesian product, if I could type correctly, prod, and that's going to be in the array, okay? And again, all of this stuff is going to make sense. I'm going to make it make sense. So total order settings equals og strat dot get this one right here. So get ind set DOS cart product, and we're going to send it the DOS tuple equals DOS tuple, and the indicator settings tuple is going to be the indicator settings tuple. Okay. And so what's going to happen here is we're going to send our dynamic order settings tuple, which is this thing right here. And we're also going to send our indicator settings tuple, which is what we will get eventually once we create our strategy. Okay. And it's going to come over to here. And what this is going to do is, you don't have to understand this, but this is just going to get the total possible combinations of whatever type of settings that we're looking to do. Okay, again, like I said, maybe we have 1,000 different possible settings for the dynamic order settings, and we have 100 different possible settings for the indicator settings, and it's going to push all those things together and return it as an array, which is going to be this. And then here we're going to have our, and then it's also going to tell us how many our total order settings that we have. Okay. Next thing that we need to do is we need to filter these. So what we're going to do is we're going to do filter the cart product array. And I definitely spelled that wrong. And let's go ahead and make sure that we spell this correctly. So filtered. All right. And we're also going to return the total indicator settings. And here it's going to be get filter cart product array. So this is just going to take the cart product array. It's going to be the cart product. Oops. All right. And so the reason why that this thing has this little underline is because we haven't created that yet. So we're going to come down here and we're going to create def, and we need to send this, the cart product array, and that's going to be an np.ind array. And so what we're going to do is we're going to say filtered cart product array is the np.ind array. And this is just basically saying we're typing this. We're typing this variable right now. Okay. And then now we're going to do total indicator settings, and that's going to be equal to 1, because right now all we just have is 1 setting in order for our math to be okay. All right. So what do we have to do now? Well, we're going to first have to do first EMA call is going to equal 12. And I'm going to explain what this is in a second. Second EMA call is going to be 13. So the reason why we're doing this is because the way it works is the dynamic order settings are going to be our first of the array, the NumPy array. So that means that this is going to be 0, 1, 2, 3, 4, 5, 6, 7, 8. These are the column numbers, okay? And then what we're going to do is we're going to attach our indicator settings to the array, which gives us that the first EMA column is 12 and the second EMA column is going to be 13. And why is that? And the reason why that is because this is 12, this is 13. So that's why the order of these things matter. If you put these in a different order, then you're going to have to make sure that they're in order the right way, the right numbers, okay? All right, so what do we have to do now? Okay, the next thing that we have to do is we have to get the filtered bools. And what is this? We want the cart product array, and we want it to be the second EMA does not equal cart product first, right? So we want this, or we could, in order to have it in, I like things to be in alphabetical order, so let's say this. So we're filtering out everywhere that the Cartesian product has the same thing, because like we don't need to test when the first EMA and the second EMA are both 100. Why would we ever need to do something like that? Because it's just going to be two of the same exact thing, which means that we're not going to have any signals or anything like that, because it's going to be the same exact thing. So that's going to be a waste of our computer power in order to do that. So we want to get rid of that, right? We want to get rid of those. Okay. And the next thing that we're going to do is we're going to say filtered cart product array equals, and then we're going to come over here. And this is basically saying, give me all of the rows where all of these columns are true, right? So this is going to return where all of the columns are true and false for this situation. And we're going to say that here. So give me all of the rows where all of these things are true. All right. And we're going to save that as the filtered cart product. Again, all of this stuff will make sense once we actually make it further down in the code. And here's going to be some logging that we need to add to this. So that way, when we're looking at our logs, we can check. So I have logger.debug cart product size. It tells us what our Cartesian product is. And then filtered cart product size. So this tells us how much we went. So let's say that this was at 1,000 and this goes down to like 900. So this is just basically telling us how much settings that we filtered out. And then when we removed, it's just going to do the math here. All right. And so that's just for our debug. It's not 100% necessary. All right. Next thing. Filtered cart product 11 is this. So the reason why we're doing this is because this is going to basically have our settings, right? So let me show you this real quick. So we have our settings index. Okay. So now what we are doing is we are going from 0 all the way to whatever the length of our filtered cart product is. And we're just going to do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, whatever. So that way we can tell what the settings are. All right. And here we're going to do this next part right here. Let's go ahead and do this. All right. So in order to get the total filtered ordered settings, right, our total indicator settings, we need to go into this array all the way up to 12. And here we're going to get the total indicator settings, or not up to 12, starting at 12. So this is going to be our total indicator settings. And we're going to grab all of the uniques and we're going to debug that and return that information. So again, this is basically saying, like, imagine if we had 10, 20, 30 for first, and then we had 100, 200, 300 for the second. So it's going to go through, grab all of those unique numbers, 10, 20, 30, and we have a total of 3 unique numbers. And then we're going to grab 100, 200, 300, which is a total of 3 unique numbers. And we're going to multiply those together to give us 9. And that's going to be our total indicator settings. We have 9 total indicator settings. Okay. Again, as always, this is going to make a hell of a lot more sense once we actually start running the code. All right. So now we have to go back up in here. So now we have our get filtered product. And then we're going to work on getting the rest of the information in the next part. All right, so one of the subscribers in chat was like, hey man, this is just getting way too confusing for me. You're going to have to take some time to actually break this down and show us exactly what's going on so far. And I agree. So what we have to do is we have to, I'm going to create this testing.ipy in B. Now, here's something very important. Inside of my virtual environment, I have this mypaths.pth. Okay, so you'll need this inside of there, and you need to have this mypaths.pth, and you need to add this. So I have e:/coding/YouTube videos, and that needs to be in this file right here. Okay, because that's, if you don't have that, then you're going to get a lot of these importing problems and all these different errors and stuff like that. And so mine is these YouTube videos. You see that here? So you're going to have to make sure that your virtual environment has that inside of it. Okay. And the virtual environment is coding. Mine is coding, vinvs, Q3 312.4. And it's this right here. It's just sitting right here in this files here. So anyways, what I did is inside of this strat2 folder right here, I have this testing.ipy in B. Okay, if you're using a regular Python file to follow along with me, then you're just gonna have to do it in the Python file. I'm not exactly sure how you would do this, but anyways, I only work with Jupyter notebooks when I'm testing stuff. So here, what we can do is I'm going to control click on this EMA cross. Well, first thing I'm going to do is import numpy as np, and from EMA cross 0 .strategy02 .ema cross class import EMA cross, right? And then I have this auto reload, so that way in case I make any changes or anything like that, it will automatically update it. So here, what I'm doing is I'm doing testing equals EMA cross, and then our first EMA length and our second EMA length. So here, this is a range, right? So what does this do? All we're doing is 10, 20, 30, 40. I have to put 41 because if I put 40, it's just going to do 30. Okay, so put 41. And we're doing here 30, 30, 40, 50, 60. And so there's going to be some overlap here. The 30, 40 are going to overlap, so we're going to be able to see what's going on. All right. So now I'm going to put my breakpoint right here, and we're going to see exactly what's happening so far that we've done. So if I click here, debug cell, we're going to come here to this this first part here, the self.log folder. So here, if we do absolute path and we evaluate in debug console, you'll see here that this is giving me the absolute path. This is where we are at right here, right? So this is where this testing.ipy in B is at. We are in strat2. So if I do all of this, and I have this dot, this is going to go back to EMA cross. It's going to go back to this folder. So if we highlight everything, right click, come down here to evaluate and debug console, EMA cross. So that's where our log is going to be, is inside of this folder right here. So you can do it however you would like. And then here we're just saying the static tuple is the static tuple, the exchange setting tuple is the exchange setting tuple, the back setting tuple is the back setting. Okay. And here we're saying our indicator settings is our fast EMA and our slow EMA, and that's going to save this, right? So once we run this through, you'll see indicator settings tuple is our first EMA length, the second EMA length is these arrays that we set in the very beginning. So now we're going to go into this function that we created. I'm going to put a breakpoint right here. So now we're inside of this function. So all we did was go down into here. We're sending this information to this. And now we're here. So the strategy, this is going to allow us to use the different functions that I've already created. You don't have to worry about these functions that are created, but I've created them already, right? So if we click this button, step into, that's going to take us into this right here, this get indicator settings DOS cart product, right? So now we're inside of here. So we have our total indicator settings, our total dynamic order settings, and our total filtered dynamic order settings. So here, this is like I told you last time. All we're doing is creating the Cartesian product of everything in this right here. Okay. So we're going to combine all of the possible combinations of the dynamic order settings and the indicator settings and put them together. So here, if we move forward past this and this play button, so you can see here the total indicator settings is 16, right? Because we have here we have 1, 2, 3, 4 possibilities. 1, 2, 3, 4 possibilities. 4 times 4 is 16. Total dynamic order settings is 4. Why is that? Because here, I changed this as well. We have 5 and 10 for the risk to reward, and 0.3 and 0.5 for our stop loss base. So what I did beforehand, which I forgot to tell you guys, is I came back over here to the tuples and variables, and I just have risk to reward as 5 and 10, and our stop loss base is 0.3 and 5, just to show you guys what's going on. So you guys, if you need to, you guys can stop your disconnect if you're working along with me, change your DOS tuple and then clear this, restart, so that way everything is restarted, then run this. And then I'm going to go ahead and run this again, debug cell. Let's click into this and we'll go forward. We'll go back over here. We'll click into this. We'll go forward again. And so now we're back. Okay. So we have 4, and then here we have 16. So now this thing, I'm not going to explain what this is doing because this is all stuff that you don't have to worry about, but we're going to be filtering the array. And once we get to the very end, we're going to have, there's 4 total possible combinations. Total filtered dynamic order settings is 4, and we have our filtered cart product. And so what does this look like? Let's go ahead and evaluate in debug console. And it's going to be 16 times 4. So we have, you can see here, this is 10, 10, 10, 10, 20, 20, 20, 20, 30, 30, 30, 30, 40, 40, 40, 40, 10, 10, 10, 10, 20, 20, 20, 30, 30. So these are all the different possible combinations. 30, 40, 50, 60, 30, 40, 50, 60, 30, 40, 50, 60. And then up here, we have all of our possible combinations. 0.3, 0.3, 0.3, 0.3, 0.3, 0.3, 0.5, 0.5, 0.5, 0.5, 0.3. Then here we have our 5, 5, 5, 5, 5, 5, 5 for our risk to reward, and 10, 10, 10 for our risk to reward. So these are all of the total possible combinations. So it's basically 4 times 16. Okay. So now if we keep stepping forward, we are here. So now we have our Cartesian product array, and we have our total dynamic order settings. Now what we're going to do is we're going to filter our own code, and that's going to be here, right? So let's move forward with this. Let's step forward. So now we're here. And so again, our column 12. So why do we have this column 12? Let's look at this again. This is column 12 right here. This is column 12, and this is column 13. This is column 11. Okay, so column 12 is the first, column 13 is the second. Okay, if we hover over this and we do this, you'll see here, column 12, column 13. 12 is our first EMA, 13 is our second EMA, okay? So what we're doing here, if we do this, is we're saying, give me row 13. I was saying columns, I'm sorry. This is row 13. So this is saying, give me row 12. Give me row 12. We got row 12. Give me row 13. We're going to get row 13. Now this is saying, tell me where row 12 does not equal row 13. So we have both of these. So what we're going to do is we're going to get a true and false, an array of true and falses. So true, false. This one is false. So here I'm guessing it's probably going to be in this 30, somewhere in this 30. Probably this one right here. This and this. This 30 equals this 30, so that's why we're going to get a false. Okay. So then what's the next thing that we do? We're saying, give me all of the rows for these specific columns. So again, if we look at this, these are the columns. So give me all of the rows for column 1. Give me all of the rows for column 2. Give me all the rows for column 3. Don't give me any of these rows for column 4. It is what this false is, what the false means. So all of these trues mean give me all of these rows for the first column, second column, third column, fourth column, fifth column. Don't give me all of them for this, right? So if we run this forward, you'll see, let's take a look. Our size is 784 for this filtered, and for the cart product, our size is 896. So now what we've done is we've filtered all of the columns that have a situation where our first EMA is the same thing as our second EMA length, okay? So we want those out. And that's what we've done here. And then this range, this 11 right here is basically our settings index, like I talked about earlier. That's what our setting index is here. And then here, all we're doing is we're just getting all of the uniques. All right. And the uniques as in we have 4. We have 4 uniques and 4 uniques for the second one. For the first one, 4 uniques for the second one. And then now we're going to return this. So if we step forward, now this is where we are at right now. So all of this should make sense so far. And again, as always, if it doesn't, you join the live stream, you ask the questions live, you join the Discord, you ask the questions in the Discord. All right, so the next step that we have to do is, I don't know, but we're going to do that step next. All right, now we're going to do some shuffling. All right, and I'll explain why you would want to shuffle a little bit later. But anyways, so if we do if shuffle bool, let's see, if shuffle bool, then we're going to do RNG equals np.random.default RNG. And then we have final cart product array is going to be RNG permutation filtered cart product. I don't know. Why is it doing this .t stuff? This stupid thing. Axis equals 1. All right. So now we are, oh, what's up, Isaac? How you doing? Just here to absorb. Okay, all right. It's all good. It's all good. So what is this going to do? Well, we're going to run the thing again, and we'll get to this point. Okay. So the next thing that we're going to do is we're going to say else final cart product array equals this dot copy. All right. So what does this mean? This means that I need to close my window because the guy decides to mow his lawn. All right, so let's just, I'm not even gonna try to explain it. We're just gonna get ourselves to that point, okay? So we're gonna turn this on to true. And we're gonna go ahead and debug the cell. And we have to run this first. Then we're gonna run this. All right, so now we're here. So what does this do? We come down here, we run this. So now you can see that we have 10, 10, 30, 20, 10, 10, 10, 20, 40, 20, 10, 20. So it's randomized everything, right? So if we run it again, you'll see it'll randomize it again. So we have 20, 10, 30, 10, 30, 20, whatever it is. So it's taking each one of these columns. If we have this and we look at this, it's taking each one of these columns and shifting everything randomly column-wise, okay? It's shifting everything randomly column-wise. And the reason why you'd want to do something like that is because if you have a bunch of data, if you have a whole bunch of data, you don't want to test every single possible scenario, because sometimes, you know, we're talking about like a very, very slight difference in one setting that's not going to make that much of a difference. And so what happens is maybe you want to skip around. Maybe you want to only test every 2 settings or every 3rd setting or every 4th setting. And so that way, if you randomize everything, you're really just going to get like the best sample out of the random samples. Okay, that's why you always hear about like randomized control trials and randomize this and randomize that. That's why there's a shuffle. But sometimes maybe you don't want to shuffle or don't need to shuffle and you're just going to test every single thing. Then that's why you could have the false. So for right now, I'm just going to have false because I'm not going to be dealing with that big of a thing. But that's what this is doing, okay? So that's what our shuffle bool is going to do. And so let's go ahead and change this back to false. And let's get rid of that. So the very next thing, okay, so we have that, we have our shuffle here, right? So now what we need to do is get the dynamic order settings tuple. So what that's going to look like is OG DOS tuple. So I put OG for like original DOS tuple. We're going to say OG strat dot get OG DOS tuple. And we're going to send it final cart product array, final cart product array. And that's all we're going to send it. Okay. And so as always, well, now as always, we're going to go ahead and come into here. I'm not actually going to do the loop. Well, screw it, whatever. All right. So let's go ahead and do this. So now we're here. All right, so we just added the get toss tuple. So we went to that point, and now we're here. And this is in the strategy part for Quant Freedom. So I've done this. You didn't have to code any of this. Don't worry. So what we're doing here is we're taking all the way up to the 11th column, because when you're slicing, if you want 11, you have to go to 12. Okay. So the reason why, again, is our indicator settings are a part of this cart product. And so all we want is the information from the dynamic order settings, because that's what we're dealing with. So we need to go up to column 11, and that's what we're doing here. So all we're doing is taking that and turning it into a tuple with this part. All right, so this is now a tuple instead of an array. And now this star thing is saying unpack that into the dynamic order setting. And so all we're going to do is take each one of these arrays and put it in the dynamic order setting. So now it has a name to it, named tuple, account risk per trade array, a max trade array, risk to reward array. Okay. And then after we do that, we are going to come down here and unpack everything and, change certain things mathematically, change things to ints where they need to be ints, different things like that. So you don't have to worry about that. Again, I took care of all of that in the Quant Freedom thing. All right. And so that's that. And the next thing that we need to do for after that is we are going to get our indicator settings tuple. So now we have to actually create this. Okay. And it's going to look similar to this right here. So let's do that now. All right, so now we have a question. They said, is the shuffling array the same thing as the random forest? And I said, no, they're not. Random forest has to do with machine learning and AI and different things like that. All we're doing is literally just doing randomization of numbers. There's no like AI involved or machine learning involved. That is a good question. I can see how that can be possibly a little bit confusing. All right, so what do we have to do now? We have to get the OG indicator settings tuple. So that is basically a function. We have to create that function, okay? And I am just going to copy this right here, and we're going to copy this, and we're going to, well, let's not do that. Let's just do this. Def this. And so what do we need? We need the final cart product is this. I'm not sure what my Copilot thing here did, but that's not what we want to do. It's close, maybe. So, all right. So what we will need to, this is nowhere close to what I used to do. np.nd array. Well, it's close. So what are we doing? We're going to do filtered cart. Oh, I'll just copy it over. Filtered cart product array is an np.nd array. Wait, what? What in the hell? Wait a minute. All right, so I had brain lag here. All right, let's get rid of these things. And let's put this back to the way it was. Brain lag, looking at the wrong part. Okay. So what do we need to do? We need to have, this is why you don't let your Copilot just do stuff, because you don't know what it's doing sometimes. So we're going to have this indicator setting tuple equals indicator settings. We're going to do the same thing that we did in the other thing. We have our thing, tuple, final cart product. We're going to have this set to 12 and forward, and we're going to complete all this stuff. So again, we're taking we're taking rows 12 and 13, which is our first and second, and we're going to turn that into a tuple, and we're going to unpack that into indicator settings. Okay. Then what we need to do is say logger.debug. And these debuggers are just going to help us if we need to see like where we are at in the code in case we're searching for some problem or something like that. So now we're going to say OG indicator setting tuple equals indicator settings, and here dot np or as type np.int. I think I should probably change that to, well, whatever, I'm not going to do that. As type np.int. So the thing is when you get the information back from the Cartesian product array, everything has to be in a float. But when we are sending certain information later on to the backtester, certain things need to be converted need to be ints. So our length needs to be an int. It cannot be a float. And that's why we're changing everything. So what we're doing here is we're taking this indicator settings tuple. We're just saying indicator settings tuple dot first EMA length dot as type int, and we're storing it into here. Okay. All right. And there's some questions about like, well, why unpack it into the indicator settings and then do it here? Why not just go, array by array or whatever it is? And the reason why is just because I like to be able to have the naming convention instead of saying like 12 or 13 or 5 or 6 or something like that. Because when you're dealing with names, then it's a lot easier to deal with, to visualize what it is that you're dealing with instead of dealing with numbers. And if you make one change, then you have to change a whole bunch of numbers and stuff. So it just gets kind of insane. So anyways, what we want to do is we want to take this, the logger, and now we want to just return our indicator setting tuple. So now that's what we would get from this. So we're going to call this. We come down here. So what we're going to do now, and all right, let's remove that. Press this. So now we're here. Same exact thing. We have our indicator settings tuple, first and second. Come down here. Now we have our OG. So now you can see the difference. Now these are ints. Up here, they're floats. 10 dot, 10 dot, 10 dot, 10 dot, 40 dot, 50 dot, whatever. Now all of these are now 10, 20, 30, 40, whatever it is. These are now ints. These are all ints and they're ready to go. All right. And so we have the next step coming up here, which is, I don't know. But as always, we will find out to actually know what, I lied. I know what's next. No, I don't. I lied. Okay. So we're going to, I have no idea where I'm at. Let's go to the next part. All right, now that I have my brain power back, let's see how long that lasts. Okay, so we have this. So we're going to come down here. We're going to return this original indicator setting tuple. And now all we have to do is return these 4 things. So we need our total DOS. All right. And so all we're going to do is return all of those things. And now what that means is we're going to come back to this class. And so you guys can see here we had this, right? So now what we will do is this. So all we're doing here is saying self.og DOS tuple, self.og indicator settings tuple, self.dos, and self.total indicator settings. So self.total DOS, self.total indicator settings. And that's exactly what we're returning as soon as we get to this point right here in the code. All right. And then what do we have to do? We have to do self.total filtered settings equals self.og indicator settings tuple dot first EMA length dot size. Okay. So all this is doing is basically going to say, well, this is okay. And then we have to do this logger debug. All right. And we set the indicator settings and all of that fun stuff. Okay. So let's go ahead and run it to this point here. And let's see what happens. All right. So we have our DOS tuple. We have our indicator settings tuple. We have our total dynamic order settings, which should be 4. We have this, which should be 16, I think. Let's see. 16. So now, if we do this, we have 56 total possible combinations after things have been filtered. Okay? 56 total possible combinations settings. All right? Okay. Yeah, I got this. Maybe I do, maybe I don't. Maybe I'm just faking it. Maybe I'm faking like I got this. Okay. And so now we are getting to a point where I don't got this anymore because now I have no idea what we need to do next. But we're gonna stop video here and we're gonna pick up when I can figure out what the hell is next. All right, so now we're at a point where we need to create a long strategy and a short strategy. Okay. And because this right now is not actually a strategy at all, this is just the precursor, right? So now we have to take what we made earlier and actually turn it into a strategy. So what we're going to need to do here is come into here and create a thing called long class.py. And inside of that, what we will need to do is import numpy as in p, then from quant freedom import footprint candle tuple, then from EMA cross strat stuff. I don't even know. I think we need to do EMA cross class import this. Yes. So from EMA cross 00.strat02 dot EMA cross class import EMA cross. So now we have to create a class called long EMA cross. And we're going to send it the EMA cross. So what we're doing here is, well, we're allowing this long EMA cross to use all of anything that is here, any of these variables, any of these variables that have self, any of these variables that have self. So we're allowing the long EMA cross to use that. Okay, so we're going to do def get long or short self. And we're going to say return the word long. Okay, that's for the backtester. So that's something that you have to add. All right, so here we're going to say set entries exits array. And we're going to send it self. We're going to say candles is footprint candles tuple. This. And the very first thing that we're going to need to do is get our first and second EMA. Okay, so we're just going to do get first, second EMAs, and that's going to be a function. So let's go ahead and go back over to here and create a new Python file called helpers. Helper class.py. And so inside of here, we're going to do all these imports. Did I? Wow. Okay. Well, all right. So what are we doing? The lawnmower guy is back. Maybe I should pause this. All right. So for this helper class that we need to create, here we're just going to import numpy as in p from quantfreedom.indicators.tv indicators import EMA TV from loggers logging import get logger equals get logger. And so we're going to do class strat helpers. And we're going to create a function called get first second EMAs. Okay. And what that's going to take is a self. It's going to take candle close prices. That's going to be an np.nd array. Then the next thing we're going to do is first EMA length is going to be an int. Second EMA length is going to be an int. And we are going to return a tuple. It's going to be np.nd array, np.nd array, np.nd array, np.nd array. All right, first EMA equals EMA TV. All right. Did it do it correctly? Did my copilot do it correctly? So first EMA is going to equal EMA TV, and our source is going to be candle closing prices, and our length is going to equal first EMA length. And it's going to be the same thing here. Source equals length equals. So we're just using what we had before, and here we are not going to return these, but I guess we'll just leave that for now. So then what we have to do, like we did last time, EMA p equals np.roll, and first EMA p0, like we did last time, np.nan. So now we'll just copy this, come down here, paste this here, get rid of these first, put second. And all right, so now we have our information here, but now we need to round these things, remember? So I think we're gonna say not rounded. I remember that. And now we are gonna do first EMA equals np.a round this. And we're going to say second EMA equals np.a round. So we have our, well, let's just get to the point where we actually return this information here. All right, so what did we do? We did exactly what we did last time, right? First EMA not rounded, we're going to get that information. First EMA around, we have our first EMA roll. So this is going to be our previous, and we have the same thing for our second. And now we are going to return that. And so if we go back over to our long class, we're going to, well, actually, if we go back over to our EMA class is what we have to actually do. So now here, what we're going to do is we're going to say self dot strat helpers equals strat helpers. Okay. And so I think if we hover our mouse over this, yes. So now we're going to import strat helpers as a class. And the reason why it's a class is because as we go, well, somebody's basically asking in the chat, the subscribers asking, why a class and why not like we have over here, right? These are just functions. And it's because at least from the way I'm understanding these things, from my own personal programming style, these are only going to need to be called once during the initiation of this, right? Whereas these helper classes, these things, this is going to have to be called in different, like in the short function, in the long function, in the live version, in the backtesting version, all these different reasons. And so that's why we just want this to be a class, because we're also going to maybe need multiple different functions as time goes on and different things like that. So that's definitely a good question. Okay. So here what we'll do, since we're able to use all of this information from the EMA cross, we're just going to do help self dot strat helpers dot get first second EMAs. And then here, I think it should fill this stuff out. Probably not correct, but maybe it is. So candle close prices. And then what we need is oh yeah, so I guess it did do an okay job. So we need self dot current indicator tuple. And that is going to, we're going to talk about that in a second. And we're going to do first EMA length, and then second EMA length is going to be self dot current indicator settings tuple. Second EMA length, okay? And well, I guess that means the next step is the question of what the hell is the current indicator setting tuple. And so let's go ahead and take care of that right now. All right, so somebody's asking, hey, I'm a little bit lost again. Can you do the testing thing and show us what's going on? Yes, I will do that in a minute, but we first, in order for our long class to even do anything, we first need to actually create this current indicator settings tuple, because we don't have that anywhere, right? We don't have that. It's not a thing. It doesn't exist. So what we need to do is let's go ahead and go back over to this DOS end cart functions.py. Let's create that function here. So I'm just going to copy this over and explain it a little bit because I am running out of energy. So here is going to be get current indicator settings tuple. we need to send it the OG indicator settings tuple. Because, right, we have an original that has tons and tons and tons of different settings in there. And all we need is the current one that we want to work with. So here we're going to have this current indicator settings tuple, which is indicator settings. And then we're going to say first EMA length is going to be OG indicator settings tuple, first EMA length setting index. So remember how I was talking to you guys earlier about those columns? We have, 56 columns, I think it was. So that's what our settings index is going to be. We want column number 5, column number, 6, column number 7, column number, whatever it is. So one super, super, super important thing here is when we are calling this function, we are sending it the setting index of a non-shuffled EMA cross. Because if you shuffle it, then it's going to be completely and totally messed up. It's not going to give you the correct setting. So you have to make sure that it is not shuffled. And again, we're about to go over that situation. We're going to go over all of that in just a second after we get done doing this. Okay. So we have this get current indicator settings tuple. And so now what we have to do is come over here and we have to create this function here called def set current indicator settings tuple. And what the hell is this? And so here we're going to do self dot current indicator settings tuple is going to be equal to get current, this right here, and we need to import this from here. And we're going to do setting index equals setting index, and OG this equals this right here. Okay. And if you would like, actually, it'd probably be better to do it like this. Okay, what are we doing here? All right, so in order to make sure that we don't mess anything up, we're going to add this. So self.get settings index. And so what this is going to do is come into here, and we're going to send it a setting index that we choose, like 0, 1, 2, 3, 4, 5, or whatever it is. And now we're going to come into here, this OG DOS tuple dot setting index, right? This is right here. And we're going to say, give me this information, right? Well, here we go again. Let's just do the thing. We'll do the thing when we get a chance, okay? And here, this is going to take that setting index, create a new setting indicator. That's going to be our current one. So the current one is basically the one that we are choosing the setting index for. Okay, and so let us see if we can do this. All right, so let's go over to this testing here. Let's go ahead and run this. Okay, let's go ahead and clear run all. This is all right. So now we have this testing here. We do set current indicator setting tuple. We're going to say setting IDX is going to equal to 3. So now let's see if we go this. Let's put this here. All right, so we have this 3 here. So now let's go inside of this. And now we're to this thing where we just said, right? So here we have this setting indexes, which is 0 through 55, because we have 56 total possible combinations. We're saying that we want it to be 3, right? So this is going to return an array of false, false, true, false, 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 whatever, right? And all right, so now let's show you guys what happens here. If we get rid of this, let's go back over to here. Let's put this on true. And I'll show you guys what happens. So let's go ahead and restart everything, run everything. All right, so now let's take a look at this 3. Let's go into here. Let's go into this. So now you can see all of the setting indexes are completely and totally shuffled. That's why I was saying If you shuffled it and we chose 3, then we would be actually choosing 0. So that's why we have to get this, because we see a 3 is way over here. And we're doing the evaluate. And so you see false, 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 true. Right? And so now we're going to say where it's true, give me the new index. So it's 26. So this 3 actually exists in the 26th index of what. So we actually need index number 26 because that's where all of the settings are for setting index number 3. Okay, because again it's shuffled. So now we're going to return that new, and then now we're going to say, hey, give me the current indicator settings for 26, which is actually settings 3 because of the shuffling. Okay. And so now we have that. So if we come over here, we do this, and we do current indicator settings tuple, you'll see that we have 10 and 60, which is our settings number 3. Okay, which would make sense because one had we had 0, we had 10, and then we had what? 30, 40, 50, 60, or yeah, because it's 0, 1, 2, 3. That's the setting indexes, right? So we had 30, 40, 50, 60 for our second length. So everything is working perfectly fine here. So that is what our current indicator settings tuple is. So if we go back over to our long thing right here, that's what this is. Grab the length of 10, grab the length of 60 if we were to have the settings to be 3, and then also grab the close prices, and we are going to return all of these things right here. So let's go ahead and do that really quickly. So now let's set ourselves up to make sure that that thing is working properly. So what that looks like is we need to do a self.first EMA, then we have our first EMAP, then self.second EMA, and then our second EMAP. So that's our previous, right? So now what are we going to do? We're going to take what we've already done, right? And we're going to say current first above second and previous first below second. So we have all these. And then our self.entries is this. And again, we're doing this self because eventually we're going to do the plotting. Remember, we're going to do the plotting here. And we're going to need to plot the first EMA and plot the second EMA. We don't need to plot anything with our previouses, so that's why we don't need a self. Because again, with the self, we're going to be able to carry that information all throughout the class. Okay? And any type of self that we create within this child class of this, the EMA cross class is also going to have access to these exit prices and entry signals and different things like that. Okay? All right, and so we have everything that we've already done before, right? And so now let's go over to this test and let's go ahead and create this. So let's go ahead and put this up here. All right, so let's go ahead and restart. And let's do this, run that. So now let's run this. So let's go ahead and go into here. Oh, we don't have our candles. But anyways, it's the same exact thing. I wonder if I debug this. It's not going to do anything. And so here you can see we have a long EMA cross. But if we have do set current indicator settings tuple, and then we do a long strat dot current indicator settings tuple. Oh, we have this set to false. Well, that's not a good look. Well, I lied. It is a good look because I forgot that here with this np.a range, I did 10 through 300 and 10 through 300. The other one I was doing at a range that was completely different. So that's why we have a different here. I was thinking it was going to be 60, but obviously that's not the case. So here we have this 10 through 300, 10 through 300, and we have the shuffle on false. And so if we did this, and we turn it on to true, we'll get the same exact thing. Even though this is completely and totally shuffled, everything still is the same. So everything seems to be working perfectly fine. So now if we have our candles, I think we've done the candles before already. So if we could grab the candles from the very first one. So let's just go ahead and load. Well, we can load the candles and then we can show the process of the entries and exit arrays in the next. All right, so for this, what we're gonna do is we're gonna do from pickle import load, and then from Quant Freedom import footprint candle tuple. Then we have our pickle path that we've made on the previous thing over here. I just grabbed this right here. And what is that looking like? Same exact thing. We're gonna do with open. Then here we're gonna put RB, which is read bytes. F, I'm pretty sure that's what it stands for. Then we're gonna say candles is footprint tuple. So this is just typing it, is equal to load F. So the pickle load. So again, you have to make sure that you click this to make sure that it works. Then we're gonna load the candles. And here we're gonna do this long EMA cross. First, we have to set our current DOS tuple, then set current indicator settings tuple. And then after that, what we can do is we're going to debug this cell. It's going to take us into the set entries and exits array. And here we're going to jump into this. So you can see here, self.current indicator settings tuple is 10 and 50. And we're going to step forward. So now we're inside of this helpers, get first, second EMAs. And you guys can see here, we have our closing prices. We have our first EMA length. We have our second EMA length, all that fun stuff. So let's scoot down here to the bottom. First EMA, second EMA, our first EMA previous, second EMA previous. Okay, so let's move forward. And so now this is just basically the same thing that we're doing here. So now we have our self.first EMA, self.second EMA. Now we're going to create what we've already done previously. You guys already know these things. We should know these things. We have our self.entry. And again, we have a question from one of the subscribers. Hey, I don't really fully understand this self thing. Self, again, just means that we don't have to, we're passing all of the variables that are associated with the EMA cross. Okay, we're passing. That's basically what the self is in a nutshell. If you need more information on it, again, that's why you come to the Discord and you ask in the Discord, like, hey, I need the beginner's guide, because the beginner's guide contains information on how classes work and stuff like that. Okay, so what does that mean? Well, now we can do our long strat.entries, and now we have our entries array. We have our entry signals, we have all of that stuff. Okay, and so now we are at a point where again, I completely have no idea what the next step is. I have to look, but as you guys have seen, we will figure this out. We will figure out what is next and what it needs to be. All right, we're at a point now where we need to just plot everything to make sure everything that we've built so far is actually working properly. And so what we'll need to do is go over into this folder. We want to create a new file. I'm just going to call it plottingfuncs.py. And from there, what we'll need to do is the following here. Import numpy as np. From Quant Freedom, import footprint candles tuple, and then import plotly.graphObjects as go. It's the same exact thing that we did in our Jupyter Notebook file. And for here, I'm just gonna copy and paste everything. And you guys could possibly be able to do the same thing. But first thing that we're gonna do is we're gonna create a function called plotting signals. And it's going to be candles, footprint candles tuple, entry signals, np.nd array, first EMA, second EMA. Those are also arrays. And so what we're going to do is we're going to grab the date times, candles dot candle open date times, and then here we have our x. And it's the same thing as last time. Fig go dot figure, add candlesticks, add scatter for the first EMA, The one thing that we did do that I want to make sure that I add is add that width thing. All right, so let's go ahead and add this width, and this one was green. Let's add this green, and I think I changed a little bit of the size here was 8. And so now we have all of our stuff, because again, it's the same exact thing here. Literally, you can just copy and paste this over and just put it into a function like we've done, like so. All right. And we have a subscriber asking in the live chat, why are we putting the plotting function on its own inside of its own Python file, basically? And so the answer to that is I'm going to show you. So we have this EMA class. So we're basically kind of doing the same thing that we've done here, right? With this, we import these functions, and these functions do something. And here, set indicator tuple, we get the set current indicator tuple. We're calling this function. It's going to return us something here. So it's going to be the same exact thing with this. We're going to say, and this plotting is very important, the naming convention here. So def plot signals, and we're going to do self, and candles is candle footprints, and then now we're going to do plotting signals. Oh boy, plotting signals. And then if I do this, if I hover my mouse over this, it should, there we go. So the reason why I'm doing this is just for the readability of everything. Like I don't want this file to have 60 million different things. Like the way I used to do it is I would have this file had all of this information all in one file, which was absolutely disgusting. But splitting everything up, you know where stuff is, and it helps make your code a lot more readable. So if we ever need to do anything with plotting, or we need to edit plotting, we know where to go, right? And so now what we're doing is we're creating a class function called plot signals. All we do is send it to candles. This handles the rest of it, and it'll plot the candles. And so, well, it should. So let's see if I actually know what I'm talking about and know what I'm doing here. So let's go ahead and do this. So all I've done is just restarted this, got my candles, got my long EMA cross. I just set my dynamic order settings and my indicator tuples. I set the entries and exits, and then now we have our entry signals. And so in theory, if I do long strat dot plot signals, and then I send it to candles equals candles, then I should get something. We get it. All right. And so let's just take a look down here, see what's going on. So you can see here, everything seems to be working pretty fine. We cross above, we get our signal. We cross above, we get our signal. Let's zoom out a little bit. Let's just see what's going on here. So cross above, get our signal. Oh, cross above, get our signal. 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 That's really interesting. Oh, wow. See that? We are barely below for like a nanosecond, and then we come up. Okay. All right. I mean, that's the computer is the computer is the computer. So it doesn't understand, like, you could add some stuff in there, but obviously we didn't. So in theory, this thing is now ready to be backtested in the multi-threaded backtester. So that's what we're going to venture towards next. All right, for the backtesting part, the first thing that we're going to do is just make sure that this works as a single backtest before we move into the multi-backtesting. As far as like testing tons and tons and tons of different possibilities. So here I just have this folder backtest, and then I have this backtester.ipynb. And what we're going to do is From pandas, import read HDF. From pickle, import load. From Quant Freedom, import symbol backtest, or symbol BT to DF, OR backtest, and footprint candles tuple. And here, like we did last time, oh, so yeah, and then we have this load, auto reload stuff. And you want to make sure that you have your kernel selected as your for your interpreter, or your virtual environment. All right, so now again, same exact thing as last time when we're getting the candles. And the next thing that we want to do is we're going to go to our long class.py, this one right here. Okay. And then at the bottom of it, we're going to make something called long strategy equals long EMA cross. And the reason why we're putting it here is because we only want to be working from one instance. So that way, in case we make any changes, we don't want to have to keep trying to make changes in a whole bunch of different places. We just want one place where we have this. And so I think I'm going to make it a long strategy like that. And from here, I'm just going to do an np dot a range of 10 to 300, 10 to 300, and that's going to go in steps of 10. And here we're going to do false, a shuffle bool. All right. And then somebody in the chat, subscriber, is asking, what does this actually do? What does this range do? And so let's just go ahead and copy this real quick. Put it over here from our import from import a range. So it just does this. So we have 10, 20, 30, 40, 50, 60. So it just basically goes from this number to this number in steps of 10. And the reason why we have to have the 1 is because of the, in order to get 300, we have to have the 1 there. All right. So thank you for that question. So for the long class, we just have this. I have first EMA, second EMA, shuffle bool. And then from there, what we will do is well, actually, another thing that we want to do is this. So let's go back over to our strat 2 init here. And what I'll do is I'm going to say from EMA cross 0 dot strat 2 dot this dot this. We're going to do long. Oh, wait, no. Whoops. Long class and long strat like this. And we want to do all. So that way, all I have to do is just do, well, in theory, I should just have to just do this. All right. So what this is doing is it's allowing us, instead of having to call like dot long class and all of these other things, we can just go ahead and call this right here. So we don't have to put all these extra things afterwards. All right. So what's next? Well, what we have to do now is we have this OR, and somebody's asking, what does OR stand for? So this is order records backtest. And so what this does is it gives you the difference between the multi-backtester and the order records backtesters. Order records only allows you to do one because it's going to give you the plot. It's going to give you each and every single trade and a whole bunch of data that if we were to give all of that data on all of our multi-backtest, it would take up a gigantic amount of space that's completely unnecessary, because at the end of the day, we're only going to want to see like the records and stuff of like 4 or 5 different things out of possibly 200,000 results, right? So there's no point. So what we're going to do is we're going to do order records backtest. And I'm just going to copy this, put this here like this, and change this to this. All right. So Our log, like I was talking about, is going to be, do we want to disable the logger? No. Do we want to disable the plot? No. And then our setting index, I don't know. I'm just going to choose something random just to see what's going to happen. Again, this could be bad. This could be good. I have no idea. Okay. And the other thing that we have to do is, where's the thing? Where's the thing? Testing. We have to, oh no, wait, I'm sorry. We're going to do that here. So this is going to take it. We're going to say we want our setting index to be 20. And we also have the ability to have our logger level set to debug or info. Debug is specifically for debugging. You're going to get a lot of unnecessary information. Info is like, okay, these are the important things we're up. Okay, and so we have our strategy, we have our disable log, we have our candles, we have all of that stuff. So in theory, if we run this, we're going to get this. Okay, so these are our setting index 20. These are our dynamic order settings for that. And then here's our indicator settings for 20. So we have 10 and 220. And so here are all of our, we've already done our plot, right? So we are all familiar with what the plot looks like here. And I'm going to run this again so that it looks bigger. And again, if we zoom in on this, we'll be able to see that everything is working correctly as far as when we come above. Looks like we had 2 crosses. All right. And here are our entries that we get. So everything is looking good. We're taking profit. We're taking profit. We're taking profit. We're getting stopped out a whole bunch. We're taking profit. We're getting stopped out, taking profit. All right. And now here is our cumulative realized P&L. Okay. And so these, you can see here that these stars right here are associated with this star, and then the X's are associated with the losses, and the stars are associated with the profits. So everything is looking good. And then here is, like I was talking about, each and every single trade. So that way you can go through, you can see how your equity is being increased or decreased based off of where you took profit. You can see the cash bar. I'm going to zoom out so that way we can actually see more of this. Even though you guys can't read the numbers, it's okay, but I just want to show you. We have each and every single trade. We have each and every single thing in case we want to do some inspecting of what's going on with the stop losses, the take profit percentages, the take profit prices, the P&Ls that we got at those, the position sizes at each and every single trade, the take profit, the entry filled, the take profit filled, and all this other stuff. So in theory, everything looks like it should right now. In theory, everything looks like it's working. So you can manually go through, and what I always suggest doing, checking all the work, and that's what we have our logs for. So let's go ahead and check the logs. So we have the Z logs. The Z log right here shows us. So let's zoom back in here so we can actually see what the hell's going on. So this shows us more information for every single one. So here we have our strategy. And then here we have our order. We are increasing our position. Our stop losses here. We're increasing our position. All of these different things that show you exactly what's happening over and over and over again. And so here we're saying our max trades has been reached, which is a total of 3. We're decreasing our position size. So you can go through and see everything that happened. You can see the date time of when we are trying to decrease our position size. You can see the date time of when we're entering the trade. This is the wrong date time. But you can see everything that you need to see. Okay, so I am under the conclusion that as long as I'm not an idiot and my programming actually worked as far as in the quant freedom side of things, that all of this information is accurate. And so now I can move on to doing the multi-back test where I can test a whole bunch of different settings and see which one is the best setting that I want to run with. All right. So before we move on to the multi-threaded back test, I went ahead and made some changes. So I renamed this folder to EMA cross, and then I renamed this folder to just backtest. Then I renamed this folder to intro, and then I renamed this folder to just strat. And inside of here, instead of having like strat 02 or whatever it is, I just have strat. And so now if we look, it's from EMA cross.strat.tuples and variables and from EMA cross dot strat dot whatever. And I also, inside of this init file right here, I removed everything and I put it inside of this init file. So what we have here is EMA cross and then the init. And then from there, I'm putting from EMA cross strat long class import long EMA cross and long strat all. And the reason why I did this is so that way when I'm doing this backtest thing, all I have to do is just call from EMA cross import long strat. I don't have to do from EMA cross dot strat dot long EMA strategy or whatever the hell the thing is called. I just do long strat. Okay, so if you guys want, you can restructure your folders however you want, however you're doing it. I'm not 100% sure how you're doing it, but mine is the most important ones that you'll have to think about is just EMA cross, strat, and changing all of these things to match that, all of your imports. If you want to go ahead and change it, you don't have to. And then putting this init file inside of the EMA cross, and then you can put all this here so that way. So that's what I've done. And so now for the backtester, we're going to need to create a new file, and I'm going to call it long backtest.py. And here we're going to have to import a lot of this stuff here. So import pickle from OS, import remove from os.path, import exist from time, import these things. This is how we're going to be able to keep track of some stuff. And then from quantfreedom.backtesters, run df backtest. From quantfreedom.core.enums, import footprint tuple candle. And then we're going to do from EMA cross, import long strat. All right, so I am just going to copy a bunch of this stuff here. So here's how we're going to structure this file here. And somebody's saying, why are we doing, somebody in the live chat is saying, why are we doing the backtest inside of a Python file instead of inside of this? And the reason is when you're doing a multi-threaded backtest, you can't do multi-threading in a Jupyter Notebook file. You have to do them in a Python file. At least that's the level of knowledge that I have. If anybody can figure out how to do it in Jupyter Notebook files, let me know. But you have to do them in here. So what I'm doing here is I'm doing if underscore name equals main, start function equals pref counter. So this is a performance counter for benchmarking. So this is going to help us keep track of how long things take. Then I'm going to say this is my database path, e coding candle databases. Then I'm going to say backtest results path is going to be the path to my databases, bt results slash backtest results long. So btr underscore long that h5. Okay. And here I'm saying check to see if this file already exists. If it does, remove it. Then we're going to print out loading candles. Then we're going to start the pref counter. So this start function is basically this whole like if main thing. Then we're going to start this, and we're going to see how long it takes us to actually load our candles, right? And then we're going to end that, and we're going to print. This is how many minutes and seconds it took to actually get the candles, right? So all of that is what we need to have there. And again, this is just for the purposes of seeing like what the hell is going on. Because if you have to load a big, gigantic amount of candles, we want to be able to print out and see like where is it happening, what's going on, what's slowing us down. Then we want to come over here and we want to do this. So we want to do backtest results equals run df backtest. And so this is going to ask us for the candles, the strategy, which is going to be long strat. And here, this is how many threads you want to use. Now, my computer has 32 threads, and this basically means that we are going to, I'm going to be able to split all of the tasks that this thing has to do and divide it by 32 and then put each one of those onto it. So if I had 32 different settings, each setting would go on a thread. They would all execute at the same time, and they would all finish in the same time it takes one to finish. So we're going 32 times faster. if I want to do 10, if I wanted to do 5, if I wanted to do 6. Now you have to figure out how many threads that your computer has. And I think if you go and right click and go to Task Manager or go to your CPU, you'll be able to see how many threads your computer has. So mine is a 16 core processor and it has 32 threads. So you will have to do the same thing. You can go to your Task Manager, go to your performance, go to your CPU, and look at your logical processors, and that tells you how many logical processors that you have. That's the maximum that you can use. So I'm gonna use 32. The step by means, let's say that we have 1,000 different possibilities. What we're gonna be doing here is we're gonna say, do every 2 of the 1,000. So we're gonna do 0, 2, 4, 6, 8, 10, 12, whatever. And this is where the shuffling comes into play, because if we have 200,000 different possibilities, we might not want to do all of them. We just want to maybe just grab random samples and figure out what kind of results are doing the best. Because you'll see in the results like that the best results are usually around the same thing. So if we had 100,000, maybe the best results are going to be like 32,600. So the best top results are going to be around that 32,600. So that's why you can do this step by. So I'm just going to do by 1. And then after that, what we're going to do is we're going to do end. I'm going to do this. End right here. And that's going to end our performance counter. And then it's going to say it took this long to complete the backtest. Now, this run df backtest, if we go inside of here, it tells us a whole bunch of stuff. I guess I got to change this total DOS. And change this to total DOS. If we scroll down to the end here, you're going to see here, make backtest data frame. And here's how we're like making all the data frame stuff, right? And it is, yeah. And that's how that's a very, very, very fast way of how the backtest works. You don't need to worry about that. I've already done all of that stuff for you. So you don't have to worry about that. But there is one thing that I forgot, which is this right here. All right, so we're going to get these backtest results as a pandas data frame, and we're going to save it to an HDF file. Okay, so backtest results.h2 HDF. Then we're going to say path or buff is going to be our BT results path. Right, we've already done that right here. And our key is just going to be backtest underscore results. And our mode is going to be W, which is write. And that's going to save our results to that file. All right. All right. So what I've done now is we are going back to the backtester.ipynb. And so from Quant Freedom import, we want to import this all backtest stats. I don't know why I named it that, but I did. So here we want to run this, and we also want to do from EMA cross import longstrat. Then we want to run our candles. Then we want to do all backtest stats. And so this is basically the same exact thing as this. So the whole purpose of this is to show us how many candles we're dealing with, how like what exactly that we're dealing with when it comes to this, because it could end up being gigantic, right? I know I was talking to one of the people in the Discord, and they were telling me that they set up something to where if they would have ran the strategy, it would have taken up to 2,000 minutes in order for them to complete, because they had so many. And so this is a good way to figure that out. So here we see that I'm going to use 32 threads. We have a total indicators to test is 900. Total dynamic order settings to test is going to be 4. And so let's go ahead, total DOS to test. So let's run it again. So total DOS to test is 4. Total indicator settings to test is 900. Total setting combinations is going to be 3,600. Then we have a total combinations after filtering. Remember, we've done filtering is 3,480. And since we have a step of 1, then that's going to be we're going to still test 3,480. So if I do step of 2, you're going to see we're only going to be testing 1,740 out of 3,480. And that means we're just going to go 0, 2, 4, 6, 8, 10, 12. We're basically going to be doing all the evens. And here we're saying total setting combinations and tests per chunk. So we're going to divide this by 32, which is going to give us 54. So each thread of mine is going to be doing 54 different setting combinations. And so here's our total amount of candles that we've downloaded. And so now we have to multiply that by, I think it's 1,740, I think. Which, or it might be this one. Let's see. Let's see what it actually is real quick. Total candles a test. Oh, total filtered settings by the total bars. So yeah. So that's how many candles we have to test. There's 55 million. And if we divide that by 32, then we're going to have each thread is going to be going over 1,722 candles. And if we add in the steps by 2, then that means we're only going to be doing 861. So this kind of really, this math thing helps you once you start to work around with your computer more. You'll start to understand like how long it takes your computer to do certain things. So for me, I think my computer is going to be strong enough to do this. I'm not sure how long it's going to take. I'm just going to pause it and we'll see how long it takes. But what we really want to do is to actually run this. And so the way that we are going to run this is going to be very simple. So let's go ahead and go back to the backtester. And we're going to make another column thing here. And all I'm going to do is do run I long backtest.py. That's going to just basically run this long backtest.py file. Okay. And they have to be in the same folder or else you'd have to do like something slash whatever. And so let's just see what this thing is actually talking about because I have absolutely no idea. Is this even going to actually work is the question. So it took us 0 seconds. We started the backtest. We're doing all 3,480. We got 55 million. Where each thread of mine is, is my computer going to explode? Is this even going to record if I have no threads? I'm streaming, I'm watching some stuff, I'm listening to some music, I'm recording a video, and I'm doing audio, and I'm supposed to be using all 32 threads. My computer is probably going to die. All right, well, you guys saw it right there. It didn't take that long. It took 33 seconds to basically test 55 million candles. Okay? So, I mean, you guys tell me another backtester that's that fast. Besides Vector BT, but Vector BT doesn't have built-in multi-threading. Anyways, so now what we're doing here, what I just copy and pasted in, is the path to the result, right? And here I'm just going to say result equals read PDF, read HDF, and it's this from this path. And this symbols BTDF results.head 10. And all I'm doing here is I'm adding in these symbols right here, these symbols, these dollar signs and stuff like that. And so we can see that so like I was saying, remember? So we are seeing here that the 2,697, 2,932, 2,800, 1,800, 1,700, 1,800, 1,700. So apparently, according to the ending P&L, ending equity, the highest is going to be somewhere around this 2,690s. And for the most part, 21,000, 23,000. So I remember we started out at $1,000 and we ended total P&L of, 26,000, 24,000. And so here are some of the different the things. And so what you could do is come over here. I'm going to grab this. I'm going to actually grab this one because this QF score means like how straight to the upside is our profit. This is not good. This means we had a lot of drawdown. This means we had a whole lot, just ton of drawdown. I mean, win rate's pretty bad. But so let's just grab this one because this one is the best, but it's still not going to be good. And let's put it into here. And let's run this. And so we'll be able to see exactly what our settings were. 10 and 20 and 10. Are you kidding me? And that's why I was saying, this is supposed to be the fast EMA. This is supposed to be the slow EMA. So the fast EMA is never supposed to be faster than the slow EMA. And that's why I just have first and second, because this is actually flipped. We're saying when the first EMA crosses above the second EMA, which usually this would be the fast EMA and the slow EMA. So usually this would be reversed, like 10 and 20. So, you know, you never know. But, okay, well, that makes a lot of sense. Oh my God. All right, well, in the very beginning, we got stopped out a bunch. And you can see here we got stopped out a lot, which is why we came down. Then eventually, with the prices going up and up and up and up, so we took our profit. We tried to take a bunch of trades right here. We got destroyed. So you can see here we got destroyed. Then, but we did get ourselves into a pretty successful trade right here. We ended up taking profit and so on and so on. So you guys can just investigate these things as you would like. Obviously, here we're still in a trade during this uptrend. And so, yeah, this 30,000, okay. There would have been a pretty long period of time that we did not actually take any trades between October 22nd and November 26th because we were in a trade for that long. We would have had to pay a lot of fees, though, for keeping the trade open. But you can see how many trades that we should have taken versus how many we did. So that's a thing. We took 28 trades. Here we took 37. Here we took 37 on this one. Let's just investigate a little bit about what's going on with this here. And again, look, 110 and 40. This is why it's like, what the hell is this? That's so weird. I would have never. Oh my God. We took so many trades. This would have been so scary to go through. Oh my God, just getting destroyed. Absolutely destroyed. Absolutely destroyed. And we recover, get it to recover, and then boom, at the very end, we're just taking profit, taking profit, taking profit, taking profit. So this is how you are able to kind of investigate like what's going on, what the best settings are. So what we can do now is we can go over here, go to the strat, go to the tuples and variables. And here, this is where I can take this, comment this out, put this bad boy back in. We have a stop loss idea. We have a, what are these? Risk to reward, trailing stop loss. Okay. Candle body above, below. So let's do that. So our trailing stop loss strategy type is going to be candle body. So we're going to be trailing our stop loss and see kind of what that does. And then here, there's like a bunch of different settings that we can test. 2, 4, 6. So now that we have this, let's go ahead and see what happens when we, I wonder if we do this. Let's see what happens. Okay, yeah. So we have to reload this. Reload this. No, actually we have to restart the whole thing. Now we reload the thing, man. Oh, wait, we got to get the candles. And let's see. All right. So now you guys can see we have 108 total possible dynamic order settings. We have 900 indicator settings. 97,000. So now previously it was taking, you know, I was doing 1 million candles per chunk. And now you look at this. Went from 55 million to 1 billion. Now this is 55 million here. So this is probably going to take like 2 minutes or something like that. So I think what I'm going to do is I am going to, why is this at 9? I'm going to do some investigation and see if we can get a lot of stuff going here. And then we'll see what happens. All right. Well, for me, I did the most brain rot thing that you could ever do. I forgot to go over to my long backtest.py and change the steps to maybe be like 2 or 3. And it's the same thing here. I should have done my steps at 2 or 3. So I did step by 1. And so I did every single possible combination, which was the dumbest thing in the entire universe that I could have done. And it took my computer 10 minutes, 33 seconds to go over basically 1 billion candles. And at one point, my computer got up to like 90 degrees Celsius, and I was scared. I almost turned it off. I was very, very scared. But that's still extremely stupidly, ridiculously, unbelievably unhinged fast. So now that so the whole purpose of this and the whole purpose of this thing is now that I know that it takes my computer about 30 or 10 minutes to do 34 million candle chunks with a step. That means that I know if I want it to be 5 minutes, then it probably needs to be half of this, like 15 million, and so on and so on. And so maybe I want to shoot for trying to figure out something to where it's like, okay, if I do this and I do step by 2, let's see, that's going to give me 17. So maybe I'd want to do like step by 3, and that would give me 10 million per chunk. And so out of the 70,000, we would be doing 23. And then also too, if I'm going to do that, then what I want to do. And so here I'm looking at this. So I have to make sure that I come over to here and set up the settings exactly like that, the same threads and same step count as this. So I'd probably change this to 3. And then I'd also want to make sure that, well, I mean, I guess that's really it. That's all I'd really want to, oh, yeah. And then I want to make sure that I go to the long class, and here I'd want to turn on shuffle. So that way we are get it. So the whole point of doing the step by, again, like I said last time, is to just to do as much randomness as we possibly can. So that way we can see what the results are, because as you guys can see here, and you saw last time, 55,000 starting at $1,000 ended us up at 689,000 in total P&L. This about the same, around this 9,000, around this 8,000, around this 3,000. It looks like they're about the same, and I'm only doing 10. If I showed like the top 30, then we would see 50,000s. So you'll be able to see kind of around the range of which areas kind of did the best for the most part. But yeah, this one, oh, this one only took 8 trades. It won 6 of them and took 2, or lost 2. 75% win rate. What does that look like? Let's take a look at this. Again, man, everybody on the YouTubes is saying, oh, you want your fast EMA and slow EMA and all of this other stuff. This should be our fast and this should be our slow, but apparently it's not. Apparently, it's the exact opposite of what you're supposed to do if you want to make a lot of money. Apparently, with the way we have things set up. And so here, this thing right here, this symbol means to take the trailing stop loss as moved. And so you can see here. All right. Let's take a look at this. Boom. And some of so we have a question from the subscriber in the chat. It's like, how are you even coming close to being able to take $1,000 and end it at 689,520? That's because, okay, so this is the super important message that you should be listening to. This strategy is hyper overfit to fit this exact scenario. Okay, so it's an uptrend and it's these specific candles, right? And this specific strategy. If this exact scenario happened again over this duration of time, then you would be poised to make a lot of money. So if we are in a uptrend, then more than likely you could run this exact strategy. And if we stay in an uptrend for this long and the uptrend looks like this, then technically you will make this amount of money. There's a high percentage chance if we get into the same exact situation, right? So that's the number one thing that you have to make sure that you pay attention to, okay? Number 2, the reason why we're able to do such crazy numbers like this is because this strategy is risking 20% of our account for every trade that we get into. And we can get into a maximum of 4 trades before it cuts us off. So that means it's 20%, 20%, 20%, 20%. So it's possible that we're getting in and we're putting up 80% of our account at risk. So here we're putting 40% of our account at risk. And that's why when we end up taking profit, you'll see that it's let's see. That's why we made $4,000 is because we were risking 40% of our account. Okay, and then I think our risk to reward is what? 10-1. Right? So if we're risking 40% of 1,000, that's $40 risk. And if we win, we're gonna get 40 times 10, which is 4,000 or 400 or whatever the hell, however the hell this works out, right? However the hell the math works out. Okay? And so that's how we are. I don't want to do math right now. Okay? So that's how we are able to see that we are able to get the amount of money that we're able to get. Because we are risking way too much on this backtest. And I didn't feel like doing math, so I had to break out the calculator. So 0.4, which is 40% of 1,000 is 400. And then a 10-1 risk to reward is 400 times 10 times 10. That's how we got a P&L of a profit of $4,000, as we saw right here. $4,000 is because we're risking $40. And we had a 10-1 risk to reward off of we were risking $400. So that's insane. So anyways, you guys, I would suggest if you're actually going to run this, that you run it at 1% risk per trade. But for the backtest and for YouTube reasons and, different things like that, yeah, we got to make it look sexy. But again, this is not fake. This is true. If you were to have $1,000, if you were to be risking 20% of your account each and every single trade, if you were to have a maximum of 4 trades, if you were to have these exact settings, and this exact situation were to happen again, or you would have ran this strategy during this time, this is exactly what would have happened. And so, yeah, you would have made, this much money. You would have made $540,000 off of $1,000. That's true. This is not like a clickbait, anything. That's real. But again, if we get into an uptrend situation, you do that again on $1,000. Hey, you'll be swimming in money like this. Be swimming in money. Let's take a look at this. What the hell is this? 1040? Are you kidding me? 6 trades, 5-1 risk to reward. What the hell? Oh yeah, that's this one. Jesus Christ, what is that about? That's insane. That's absolutely insane. So how does that happen? So our account now sits at 200 and whatever thousand. So if we're risking 20% of that, we have a 5-1 risk to reward. So what is that? 229664 times 0.2. So we're risking $45,000 times 5. So we basically just something like doubled our money, I guess. Oh man, that's a lot. That is a lot. Anyways, yeah, so let's move on to the next part.